So sorry about that. My screen just went dark and I think the computer restarted or something. So I actually did some the rest of the problem well, off screen or off the video. So just to again, once you set it up like this, you're just taking derivative of both sides, and so you can see that I've just ran through the video the way we normally do. I'm sorry, ran through the implicit differentiation technique. This is from the derivative of y squared. This is the derivative of 15x. This together is the derivative of that because you have to use the product rule. And then, of course, the derivative of 12 is 0. Then I went from here. I plugged in the 0.44. Plugged in 4 for x and 4 for y. Ended up with negative 17 over 8. Okay, so that was number 2. And then this is number 3, 6 sine x plus 2 cosine y, 6 sine x plus 2 cosine y, and negative 6 sine x cosine y, negative 6. Okay, so this again is number 3. So I've rewritten the problem, and we're supposed to evaluate it at the point 4 pi 7 pi over 2. 4 pi 7 pi over 2. So first of all, I've got to take the derivative. Derivative of 6 sine x is 6 cosine x. Derivative of 2 cosine y would be negative. So that would be negative 2 sine y dy dx. And that's going to require the product rule. So that would be negative 6 cosine x cosine y minus 6, actually plus 6 cosine x, sine x sine y plus 1 equals 0. So then I go ahead and plug all that stuff in. So 4 pi for x. So that would be cosine of 4 pi is 1. So that'd be 6. Sine of 7 pi over 2. Think about sine, it goes like this, right? So that would be 4 pi over 2, 5 pi over 2, 6 pi over 2, 7. So that'd be negative 1. So that would be plus 2 dy dx. And negative 6, that would be negative 6 times cosine x. Well, cosine of, we were talking about that's 1, right? Yep. And cosine of y. Cosine, remember on the 7 pi over 2's, on any pi over 2 is going to be 0. So that whole thing is gone. That's nice. And then this is going to be plus 6 times sine of x. Well, sine of 4 pi, that's also 0, so that's gone. And we have a plus 1 equals 0. So what it comes down to is we have 2 dy dx is equal to negative 7, which means dy dx, when evaluated at that point, is equal to negative 7 halves. Let's check that. There you go. So there's a couple examples from homework 7. So you did homework 7, problem 2 and 3.